Hello, I'm Brian Holt. I'm in charge of the sensor interfacing system.
Hi, I'm Adam Popper. I'm a senior in electrical engineering, and I'm in charge of the reporting subsystem.
Hi, I'm Seth File. I'm a senior electrical engineer, and I'm in charge of the power system subsystem.
Hi, I'm Aditi Pillai. I'm a senior in computer engineering and in charge of the software applications. Our team is the Team Solar Scouts, Team 34. We're in charge of making the AgGrow data cart. What our cart does is meant for end users such as farmers that go through fields to count corn stalk, as well as get the temperature, relative humidity, and sunlight. Having this data now through this device can now be shown to your phone, save the data, and makes it very easy to get multiple data fields of our fields to be now stored on a microcontroller and onto your phone. So here we're showing the iPhone app off, and you can see the connection between Bluetooth. It's connected, as well as the data here and the data here are similar or the same, as well as changing in real time. If you look closely, the humidity, temperature, and lux are changing and comparable to the sensors. On top of this, it's also changing here, and the longitude and latitude have finally gotten the GPS signal. Now, if I want to save the save report feature to work, I have to click on the button. It'll now let me save it to files, which is time-stamped as you can see. And if I click onto the files, I'm sorry. This is the last one at 12:13. You can see the data. The corn stalk being at 1 because it didn't change, the humidity, temperature, sunlight intensity, longitude and latitude, plot rating and heat unit. I'll pass on to Seth to talk about what exactly plot rating and heat unit exactly mean.
All right, so plot rating is it takes our corn count and divides it by an initial count that the farmer would have dropped in a certain amount of the row of corn, and it's just a percentage value. Heat unit is the average high temperature of the day, subtracted by adding the average low temperature of day, divided by 2, and subtracting a factor of 10 for corn, which gives you the heat unit. Now we'll have an observation of the accuracy of our sensors. Our ambient temperature here is 23.68 degrees, and our relative humidity is around 20%.
So, as you can see here, the relative humidity and temperature from this calibrated relative humidity and ambient temperature sensor are fairly close to the values reported on the touchscreen LCD. And then if we go over here, you can see that the ambient light intensity is also very close to the value of the red lux reported on the LCD screen.
Which reported to be 603 here, as well as down here, 604, as there's a slight delay in the data transmitted, but it is very real time.
At first, once the system's powered, you're asked for user ID. In our case, we'll enter 765. And then, say we entered the wrong user ID, we would hit the clear field. And then if we hit the enter field before having a user ID entered, it asks you to finish your ID. So for the sake of this demonstration, we will have it enter 876, and then we'll hit enter, which brings us to our main screen. And our main screen, the way that we're allowed to change the sensor interfacing as prompted down here, says touch sensor values for settings. So let's say we wanted to change the way that the humidity sensor is pulled. So when it comes to relative humidity, we can change it between 0, 1, 2, 3, 4, 5, or 6 seconds. So say we wanted to change it to pull every 4 seconds, or if we wanted to change it to pull every 1 second. For the sake of this demonstration, we're going to change it to 1. And then once we hit start data,
This is a simulation for the corn stalk count. We have our corn stalk planted to the right of us as PVC pipes. We also have our phone on top, also having the data, and here we're going to show the corn count. Let's begin. You can see the count being to 10, the humidity, the temperature, as well as the luminescence.
All right, so this is the teardown video of our cart. This width here, less than 29 inches, meets our requirement for width. Yes. We'll start with the teardown. This is the GPS antenna. This is our temperature, humidity, and lux sensor. This is our phone holder for our data transmission. This is our screen. Down here we have our battery, our microcontroller PCB, our 3v3 buck converter PCB, our 5-volt buck converter proto board, our GPS module, and our LiDAR sensor.